Welcome everyone to the latest Trees Around the Globe Student Research Campaign webinar. This one is continuing with your Trees Around the Globe Student Research Campaign projects, looking more in depth at online tools, story mapping, and the NASA GlobeObserver trees and land cover tools for student research projects, including an awesome student research project on lime trees in Croatia by our friend Antonela, who is on right now. So she will be presenting shortly. So once again, welcome. Here's our core campaign team. You've all seen this before, but I like to keep it in the slide deck. All right, so today's webinar agenda. After the introduction, Dr. Schumann is going to talk about insights on Europe's small-leaved and large-leaved lime trees from the European Atlas of Forest Tree Species. And it's a little different than what he's done before, but what he has planned for you, and it leads in nicely to the student presentation by Antonela from Croatia. Then after that, I'm going to show you a combination of things, and this is just to show you just some things that you can do for a research project. And it's going to be a combination of, I'm going to show you a live, well, not live, but a recorded tutorial of me using the app to measure tree height at a local tree. And then I'm going to show you that I actually took a tree height observation in January of this year, and I did March of last year, and then we're going to show a combination of that. And I also took a land cover observation of that same location. I want just to show you some things that I found, along with how it compares to some really cool ICET2 data that I found as well. And then Dorian will be talking to you about basically how she took tree height observations at the same time as land cover observations and why this is important for student research. And then the final main topic will be with our great friend and colleague Peter Nelson. He will be digging deeper into story maps and creating maps, and looking more into some of the things that Dorian presented over the last several months with story maps and creating this or using story maps for student research. And then we will have any final Q&As at the end of the webinar. So hopefully you can stay with us for the entire time. We will try not to go as long as last time. We went about 2 hours last time. So, but everybody who was here really, really seemed to enjoy it. And, all of us lost track of time, and because there was so much information that we included. So continuing on here, as you know, I always do a little metric system here. This section here with, where the data is coming from and how much data we have. And I'm going to just go all the way down to the bottom for full campaign. And as you know, we started the campaign year 1, September 15, 2018, that started at the same time the ICET2, the Ice Cloud and Land Elevation Satellite 2 satellite launched into space. And for, like that 2.5 years that it's been in space, that's how long we've had our campaign going so far. And in that time, up to today, we have had over 28,000 tree height measurements from students and citizen scientists from over 12,300 global sites. We have over 17,800 land cover measurements at over 12,000 global sites, and we have over 17,000 greenings measurements. And these are all from students, okay? Because as you know, the greenings is not part of the NASA GlobeObserver. It's not a protocol in the NASA GlobeObserver right now. And they come from 571 sites. So basically what that means is we have over, or almost, I should say, 63,000 measurements that were taken during the time of the campaign so far. And as you know, not all these observations are coming directly from campaign members, but we showcase this because a lot of them are, but we also showcase this is because this is awesome data for students to use in their research projects. And as you remember, we're focusing this part of the campaign on the IVSS, which, the last day to submit your projects and reports to the IVSS on Globe is March 10th. And we will actually be having a webinar on March 9th. That will be the next webinar, and you'll be able to see that on the website, and then you'll see it in the, in the March brief that comes out from the Globe program. But, as you know, we have all the webinars that we've ever done for this campaign are archived on our webpage, on the campaign webinar section of the web pages. Right now, we have active participants from 53 countries. And then also we have 39 blogs up there. And every once in a while, I do a count on the views of the blogs, and we've hit over 103,000 views on the blogs. And these are blogs from everything about ISET2 to the campaign to different tutorials that Peter Nelson has been involved in creating, some story mapping stuff. So anything, campaign related, even ones where students have been presenting, we focus on those as well. So we have lots of really cool blogs up there for you to take a look at, and some of them have been viewed 6,000-7,000 times. So those are the most popular ones. But what you're looking at here on this map are all the observations that have come in under trees, land cover, greenings, and the carbon cycle since the beginning of the campaign. That is a lot. Okay, there is a lot of space up there when you look up towards Canada and you look up, in Russia, parts of Asia. There's a lot missing there, but what you're looking at this map is really awesome, because this represents those 62,899 measurements from the 24,000. Oh, I missed a number down here. Sorry about that. That number should actually be the 24,970, coming from around the world, around the globe community over the last 2.5 years. All right, so as you know, we're in this second phase where we're focusing on the science that you learned, and we brought to you the first phase during September through December of the science, that being the science of tree height, land cover, greenings, and carbon cycle. And then we're focusing now on taking that science and making it understandable and just assisting students and educators in that process of, how do I get to that next step of using that science, using that data in student research. And we hope that a lot of you students and or students of you teachers are going to be submitting some IBSS projects. And I did hear from several that was a lot, well, actually pretty many people that are going to do it, a good 10 to 12 groups that got back to me and said, hey, we're planning on submitting now. That doesn't mean they actually submitted yet, but, fingers crossed that everything will be okay and they will get their projects submitted on time. As remember, that is March 10th is the deadline, and that's March 10th. I believe it's, what time zone is Boulder? I believe that's, it's not Central Time, that's Mountain Time. So I believe that's Mountain Time. So that's Mountain Time in the United States. So whatever time it is right now here, right now, and where I live, it's almost 2:15 p.m. So it would be like 12:15 p.m. So that's when you have to submit that. So right now we're in that second phase of the year 3 scaffold. So without further ado, I will pass it over to Dr. Christopher Schumann, and he's going to be talking again on insights in Europe's small leaf and large leaf lime trees from the European Atlas of Forest Tree Species. Take it away, Christopher.
Thank you, Brian. It's a pleasure to be back with you and to, as we have done before, take a little virtual field trip to see part of the world that well, we just can't get to right now. But the primary goal is to highlight the European Atlas of Forest Tree Species. And we selected the section on the large and small leafed lime trees simply to tie in with our student speaker today. But it's an opportunity for you to look for this online and to see how it might work into your interests, things that you'd like to know about European trees. So this is just a couple of examples of really beautiful photographs that they have on their cover, and including a bit of the carbon cycle there at the right, where a trunk is decomposing and turning back into soil. So it just gives you an illustration of some aspects of trees and all their beauty. So next slide. So one of the fun things for me is that I don't know a lot about some of these topics that I'm discussing with you, including the word chorology was new to me. But this is some maps from the section on Europe's small and large leaf lime trees, and showing their distribution as in green is where they are native, and with larger dots for where they really are very concentrated. And so the small leaf on the left and the large leaf on the right have different ranges and obviously different temperature sensitivities. They don't tend to like it being super cold, and they don't tend to like it being super hot, is one thing that you could take away from this, or hot and dry at the very least. So just an illustration of the kind of insight that you'll get if you go to the European Atlas of Forest Tree Species and check it out. Next slide. And another illustration of just kind of the beauty of these trees, and also have to mention that is these standalone trees, which are easiest to measure with the clinometer. And we'll see a couple other examples as we go through this. Some of the detail that's in the article that I'm excerpting is got some fun facts basically, including the Coppicing was another term that I was not familiar with, and we'll discuss that a little bit later. But basically, a long-term woodland management strategy that is been identified in historic logs even, and we'll touch on that a little bit later. Some interesting things to know about the small leafed lime here. And next slide. And there's a large leaf, also another excellent candidate for measurement for globe trees, if anybody can, of course, get to Slovenia. Really pretty sizable trees, 30 to 40 meters in height, and beautiful straight trunks. They are excellent timber for many uses, and very long lived. So this is a pretty persistent part of the landscape across much of Europe. So the one thing that I learned from my father about growing trees was that you want to knock off the sprouts at the base of the trunk to maintain the main growth, and to assist the health of the tree. There's another word that I wasn't familiar with, epicormic. Again, just fun to explore these interesting resources. Next slide. So just a close-up of the texture of the trunk, and also the shape and edges of the leaves. The word that was new to me here was cordate, or heart-shaped. Boy, that's a pretty attractive leaf, and a pretty distinctive one too. So one suspects you'll be able to, those of you that are in Europe will be able to go out and find some lime trees and basically leverage this content pretty easily. Of course, doing it safely, considering the conditions we're all living under. At any rate, next slide. The fact that you can make tea with the flowers is kind of cool. I'm not sure how valuable the seeds are for other purposes, but pretty clearly the trees reproduce pretty widely. But after the tree is already reached a pretty substantial maturity, so doesn't happen rapidly. I don't know, maybe somebody on this call knows if the the tea made from the flowers actually does have anti-inflammatory properties. So just another aspect of the knowledge that's in this article. Next slide. And I don't know about you, but I used to like to climb trees when I was a kid. I don't do that anymore, but that sure looks like a great place to go vertical and you know, see the world from up above. But there's all sorts of things that you can do with the tree itself, and obviously people have been using it for many purposes for literally hundreds, if not thousands of years. So, and of course, they apparently make a pretty good urban tree along the Unter den Linden, another word for a lime tree in historic Berlin. So you may have these in the cities where you live as well. Next slide. This is just a general wrap up. The tree species, as you might suspect from how widely it's distributed, is generally quite disease resistant. There are some things that can attack it over time, and obviously they do age out at some point. But the fact is they are a very long-lived part of the landscape, and so obviously have pretty good insect and disease resistance. And this is a little more detail on coppicing, and thanks to my fellow member of the core team for finding this Earth EOS article. But coppicing is a technique which involves repeatedly harvesting smaller trees every 30 or so years, but leaving an upper story of larger trees for longer periods. So this ensures a steady supply of both firewood and construction timber. This is based on oak trees, but it applies also to a number of other trees, including limes. Basically, what this does is by harvesting small trees and leaving an overstory, creates a distinctive tree ring pattern where the larger remaining trees have a growth spurt because there's less competition for nutrients in the soil, et cetera. And somebody actually went through and analyzed thousands of oak timbers for more than 1,000 years of these samples being available. And they basically indicate that this this forest management practice dates back to the 6th century. And I think that's a really cool thing to know about forest management. Even though I can't imagine managing an oak forest, they're big, tough trees, quite this way, but apparently there was enough social coordination that they could do this. So just another element of basically trees around the globe. So I think that's the last slide, Brian. And thanks for your time.
All right, thank you, Christopher. That was great. There was lots of good information on there, like in some of those terms that you brought up that you weren't familiar with. I'm not familiar with those two. I think I heard the chordate at one point, but you hear that in different ways. You spell it with a C also, a CH, sorry, and it's totally different meaning. But yeah, so yeah, thank you for that. And I think it leads in well to our feature presentation today. And our feature presentation today will be how the lime tree affects the lives of people and the environment. And the student is Antonela Nikolic, and mentors Anaga and Marina, and she is from the 3 Primary Škola Varaždin in Croatia. So I will go ahead and stop sharing my screen, and then Antonela can begin. But I just want to say that I've talked with Antonela a little bit. I believe it was maybe in December, could have been January, and she showed me just the research that she was doing with the lime trees, and it's really, really cool stuff. And you're going to see this, what she's done to to figure out the math and the science involved with figuring out how the lime tree affects the lives of people and the environment. But I won't steal any of her thunder right now, so I will stop sharing. And Antonella, if you like, go ahead and start sharing.
Okay, thank you. Just let me find my presentation for a
All
sec. Just do this. And here we go. So, hi everyone. I'm Antonela, as Brian said. I'm from 3rd Primary School. Mentors on this project were Anica Vragovic and Marina Balajinec. And today I'm going to be presenting to you how our lime tree affect the lives of people and the environment. So let's begin. So the effects of climate change are being felt all over the world. Hurricanes are more frequent, sea levels are rising, um, earthquakes earthquakes are happening, entire communities like coral reefs are disappearing, and as the most common cause of this is mentioned man. So with the fact of climate change, I first met when I was 10 years old in my science class, and I wanted to contribute to the protection of our planet uh, and actively participate in environmental observation. So I joined the GLOBE program. As a part of the GLOBE program, I've been measuring and watching our lime tree in front of the school for 3 years now, and I noticed that this year, bud bursts started 2 weeks earlier due to climate change. Um, I learned a lot about nature and ecosystems, and I learned that all ecosystems are connected and that we are all dependent on each other. So my goals for this project were to develop awareness of human connection with nature, encourage students to actively participate in environmental protection and nature protection, encourage school authorities to plant more trees around the school, and link mathematics with nature. So I'm gonna just mention what facts I take into account when calculating all this math and connecting this science. So by the Swiss Federal Institute of Technology, the nature is the most effective measure for nature conservation. And the best way to change the world is to change ourselves. So by the actual math, scientist Houston once said that 1 square meter of leaves produce 500 milliliters of oxygen per hour, and one Croatian scientist, Tsar, said the average person breathes 12 times per minute in a standby state, and that breath has 500 milliliter, of which is 79% oxygen. So a little bit about our lime tree. Um, so our lime tree belongs to the species of small-leaved lime. Uh, the small-leaved limes are delicate trees that grow up to 18 meters. The canopy is dense, inute, conical, and symmetrical, and later on hemisphere rounded and wide. The flowers are pale yellow and with wing size and pleasant smell. The lime tree blooms between June and July. The fruit is multi-seeded nutmeg, uh, which is with pear-shaped and reddish in color. The lime tree requires loose, deep, well-drained soil. Um, and then drives to another types of soil like is adaptable to different pH reactions of soil. The lime tree likes the sunny to semi-shaded positions, and it tolerates urban planting conditions like pollution, compacted and alkane soils and poorly drained soils. I took this from scientist Drian from Croatia. So the questions I asked myself when I wanted to do this project is how much lime tree produces oxygen in 1 hour, 1 day, and in 1 year, and how much oxygen does the average person breathe in 1 hour, 1 day, and in 1 year. So in order to calculate how much oxygen does our lime tree produce, I took one leaf and calculated its surface using millimeter paper. As you can see on the photos, I calculated there are 42 centimeters square. And in order to get approximate numbers of leaves on a lime tree, I used this wire cube with a volume of 2.2 decimeters on third, and then counted the leaves in it, which is 16 leaves. Also, you will see on the next slide that I imagined the lime canopy as a cone, and with that volume of that cone, I calculated how many cubes are in the lime tree and calculated the leaves in lime tree, which is 174,569. So you can see that cone right here, that the volume of that cone is 2,400 decimeters on third. So you can see the radius here and the cone itself. So from this data and the facts that I said at the beginning of the presentation by the two scientists, Houston and Sad, I calculated how much one leaf produces oxygen in 1 hour. That is 2.1 milliliters in one hour. Whole tree produces around 367 liters of oxygen. In 1 day, that will be 8,808 liters. And in 1 year, that will be 3,214,920 liters. So next up, I calculated the amount of oxygen that one person inhales. So we said at the beginning that in one breath, there are 500 milliliters of air, and 79% of that is oxygen, which will be 395 milliliters of oxygen in a breath. Since in 1 minute we breathe 12 times in a resting state, we breathe in around 4,740 milliliters of oxygen. In 1 hour, that will be 284,400 milliliters. In 1 day, that will be 6,825,600 milliliters of oxygen per day, and in 1 year that will be 2.10 on 9 liters of oxygen. So since I did this project for my math class, I took my school as a use. So there are 391 students and 43 employees in our school. So that means that there are 434 people in our school. So that means that we need 123,429,600 milliliters per hour of oxygen. In 1 day, that will be 2,962,310 liters of oxygen, and in 1 year that will be around 1.8 times 10 on 9 liters of oxygen per year. In conclusion, our lime tree annually produce about 3,240,920 liters of oxygen, and employees and students of our school need about 1,081,243,000 296 liters of oxygen. In theory, it is necessary to plant 336 lime trees in our schoolyard. And I'm extremely pleased to have calculated this research to highlight the importance of tree planting and their usefulness and lack of in the environment. But I am aware that we cannot plant 336 lime trees in our schoolyard. But I hope that that school authorities will plant at least 2 to 3 trees so we can be closer to nature. I also hope other schools in Croatia do the same as the project says. I enjoyed the following and measuring the lime tree in front of the school and using mathematics. Mathematics is really all around us and is the foundation of all natural sciences. I'm always happy when I can apply math knowledge to concrete and live things. That's all. Thank you for your time. Are there any questions?
Hi, Antonela. This is Peter Falcon. Yeah, I just want to say congratulations. This is an amazing presentation. You need to see some of the comments that people are writing. They're very impressed with your work. We do have some questions for you if you have some time. Tracy Elstrom from the US asked, do you see an increase, a faster temperature change along with any earlier bud burst?
No, I don't think so. The 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 temperature of air increased during the summer, and I can see that in winters we have like less snow than before. We can see that even now we can, like the other day we were literally in t-shirts and in short because it was like really warm, and I can see that difference how the climate change during the years.
Thank you. We have another question from Anna from Argentina. So you're getting questions from all over the world here. There's so much people like your project. It's really cool. And she asks, you may have gone over this already, but she asks, how do you calculate the amount of oxygen produced by each leaf?
So how I calculate uh, the the amount of oxygen that each leaf produce. So we said at the beginning of the, just a second so I can scroll so I can describe it visually, so I'm talking like air. So as I said it in the beginning, this scientist Tsar said this scientist Houston said that 1 square meter of leaves produce around 500 milliliters. So I calculated, I supply the amount of the area we calculate and the amount of oxygen it produced by the equal size. So we actually get just, I write that on the paper because I know that someone will ask that. So yeah, one single leaf will produce in 1 centimeter square, that will be 0.05 milliliters of oxygen by 1 centimeter square. So when I calculated that one leaf is 42 centimeters square, I just multiply 42 by 0.05 and then get 2.1 milliliters of oxygen per hour. So I hope that explains a bit, I guess.
Okay. We have another question for you from the US, from Brian Campbell. First off, he says it's an amazing presentation, and he wanted to know, do you plan to bring this information to other schools?
First of all, thank you. I was hoping after like in the next weeks in school, first presenting to my school and my principal. After that, to town authorities, and then I hope to like get to other schools. But I don't know, since the COVID happened and we're in the pandemic, I don't know how will that happened, but that is kind of my goal. So
You know, just a couple more questions. You have that really cool cube looking thing. Can you explain that? That is so cool. I want one of those.
so my teacher from math actually made this a couple years ago. So let me just show you. So you can see that is wire a cube. Um, they are symmetrals going down with another color, so we can like point them out. And they say they are together at all times, so they cannot break. Also, some some I think the neighbor of the school helped us build this couple of years ago. I actually need to ask my teacher how she made this. We didn't talk about much about this cube exactly. So yeah.
My colleague Brian and I were looking at that and we thought, that's so cool. We want one. So just a comment. So one more question from Diana from Croatia. She asked, did you calculate a production of oxygen just in the months when the lime has the trees on, or months or vegetation periods? I can ask it again. Did you calculate the production of oxygen just in the months when the lime was on the tree, or did you also calculate the oxygen when there was vegetation periods as well, or in other months?
So we actually calculated everything before like leaves fall and leaves were like on and then like green, and we can say like healthy, I guess. But then we forget to take pictures, so we took it after it. So it's like not a lot of leaves on the tree, as you can see on the photos. And yeah, this all information is calculated with like green leaves when vegetation is on. I didn't calculate with vegetation off. So yeah.
And the last question. The question is, do the trees produce different amount of oxygen in different stages of their growth, of their lifespan? And do they produce different amounts of oxygens in different seasons?
Well, yeah, because during the time, the photosynthesis is basically how the trees in general produce oxygen. So if there is more sun, of course there will be more oxygen. But if we took like average, like the average that is always light and sunny, because we cannot actually calculate how much lime tree produces oxygen in like a year, because there are different days, there are different stages of vegetation. So we will to calculate the exact number, we will need to count each leaf by hand and like go each day how much leaves are on the tree and how much sun the lime tree is getting. So yeah, there is a difference. But if we do the average day, that will be like the closest to what I get by producing oxygen.
Thank you so much. You gave some amazing answers. Your presentation is awesome. I encourage you to read through some of the comments that people mentioned. We have people from, I want to say, 10 different countries, and you have great responses. So once again, thank you for your time. Thank you for a wonderful presentation.
Okay, just so I stop sharing now. So
yeah, I believe so, right?
Yeah, you can go ahead and stop sharing.
Okay, thank you.
Yeah, thank you so much, Antonella. One thing I wanted to mention, that when I was talking to Antonella last month, and she mentioned this earlier, that one of her goals is to take the information that she's learned and the project that she's done, and taking it to decision makers like the mayor in her town and people like that who can take the information that she brings to them and says, hey, if we plant more of these trees, these lime trees, here's what it's going to give you. Here's what they're going to give you. They're going to give you this oxygen. they're going to, you know, better the environment. They're going to pull in that carbon dioxide from the atmosphere, you know, and, you know, and going to all the different schools, you know, and having the, you know, the people there understand what these plantings are. You know, you're definitely, Antonella, in the right step of what, you know, needs to be done. You know, you got to get the people who are involved and can make those decisions in a local area to plant more trees, to get the word out there to more people that you might not be able to get the word out to as easily as they can. So yeah, so thank you so much for the presentation. And as always, you know, I really enjoyed hearing that and talking to you and having you present at our webinar. And you know, with the questions and the comments and the people who have come in here from, you know, as Peter mentioned, 10 different countries, you know, they were looking forward to your presentation. So you know, we want to wish you definitely the best of luck, and you know, you have to keep us, you know, up to date to, you know, what happens with your project and, you know, where you take it next.
Okay, I will. No, don't worry. Thank you all.
Thank you. All right, let me go back to the presentation and back to sharing my screen. So now we're going to move into a little bit about looking at the tree height observation. Since we talked a little bit about seasons, you're going to see that there's, you know, some of the observations that I'm taking here. I'm going to show you a little bit about this. First thing you're going to see with, you know, me here. This is back from March of last year when I was doing a tree height observation in my neighborhood, and it's on a Bradford pear tree. It's a Bradford pear tree is not a very resilient tree. It's very fragile. It has a shallow root structure. And you'll see, you know, you'll see an example of how that's the case soon. But I want to show you this, and this, you know, I'm going to probably play all of this, but, you know, some of you, I know when some of you emailed me at some point directly saying, you know, can you, you know, show us how to, you know, easily do a tree height observation using the NASA Global Observer, because there's nothing specifically out there that shows this. And this video that you're going to see here, we're also going to repurpose for in April. And, you know, heads up, there's most likely going to be the April, it will be a 2021 Trees Challenge that will run from April 15th to May 15th. As you remember, we were going to have one last year, but because of the pandemic, we had to postpone it until this year. But this video that you're going to see here will be repurposed, and it's kind of a step-by-step demo showing you some of the information that you need to do, you know, in order to take a tree height observation. So I'm going to go ahead and play this video now. It's about 8 minutes, but it shows you, you know, all the steps you need to do in order to take a tree height measurement. And when you get this done, it won't take you when you get this figured out, it won't take you 8 minutes to take a tree height observation. It'll take you a minute to maybe 2 minutes to do a tree height observation once you figure it out. But this is a little longer because I wanted to show you step by step what needs to be done. And then after this, I'm going to show you the data that we got from this observation and another observation that I did last week at the same tree, and then something pretty crazy that happened between the observation you're going to see here and the one I did last week. And then I'm going to show you also that I did a land cover observation. And then we'll go to Dorian, and she will talk to you about how she did land cover observations at the same time as she did tree height observations in her location. So let me go ahead and start this. Hi, this is Brian Campbell of the NASA Wallops Flight Facility. I'm the tree science lead for the NASA Global Observer. Today I'm going to talk to you how to take an actual observation using the NASA Global Observer Trees tool. So in order to get started, you first have to go through the introduction. In the introduction, it will ask you for some very vital information. You have to input your height. And if you input your height, what the app will do is it will then estimate the eye level of your phone's camera from above the ground. And also it'll estimate your stride based on that height. You also have to determine if you're going to use the metric system or the English system in your observations for the units for your tree height measurements. So what we're going to do is we're going to get started taking this observation. Before we do any of this, I want to make sure that you're aware that in order to do this the way you should be doing it, you want to be able to do this safely and legally wherever you are. If you happen to be on private property where there's a tree, make sure you get the permission, but you want to make sure that you do this safely and legally and follow all local jurisdictions and laws in your area. So let's get started. So we're going to go into the trees tool, and we're going to just go click trees, new tree observation. And what you will get the time, you'll get a date stamp, time and date. Make sure that's right. And then what it's going to do, it's going to ask for service conditions. We want to know what's happening around your local environment when you're taking the tree observation. Meaning, is there snow or ice on the ground? No. Standing water? No. Is it muddy? No. No dry ground. There are leaves on the trees, and it's not raining or snowing. So then once you do that, you're going to measure the base of the tree. So this is really cool because you click next, measure base, and your camera will open up. And you're going to make sure that your phone's camera is always at your eye level. So keeping it at eye level, I'm going to go to the base of the tree, and I'm going to align this line, this white dotted line, to it. There we go. It's at the base of the tree. I like that. I'm going to continue to measure the tree top. Keeping it at eye level, you're just going to angle the phone up to the top of the tree. And there we go. We're at the top of the tree. We got the top of the tree. So what we're doing is we're measuring the angle from your eye level to the base of the tree and the top of the tree. And the phone your phone uses the internal magnetometer, and the app uses that information to calculate these angles in order to get you to measure the actual height of the tree. So we have the base and we have the top. Now we want to take a picture of the tree. And this happens to be a really pretty Bradford pear tree. So we're going to click on that, and it takes a picture of the tree. Now, since I'm on a flat surface, what I'm going to do is I'm going to walk normally to the tree. Okay, and you should ultimately be about 25 to 75 feet away from the tree. I'm about at 25 to 27 feet away from the tree. But as I walk towards the tree, I'm going to walk normally. That's super important, to walk normally to the base of the tree. Normal steps, because that's what the app based your stride on with your height that you input into the introduction section. I should also mention that there's a tutorial section in the app that you need to do before you start, so you can learn exactly how to do the tree height observation. But now I'm going to walk to the tree, and I'm going to walk normally to the tree, normal steps, counting my numbers out loud. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 steps. So you input that into the box, 18 steps. Now, what it's going to do is it's going to go to the location. It'll give you the estimated latitude and longitude of the tree. Okay. It'll tell you what you think, what the app thinks your estimated accuracy is. And if you like it, you can hit set position. But if you don't, what you can do here, you can go to a map. And this map, you can move with 2 fingers and say exactly where that tree is. Okay. So I think it's right about here, okay? So once I set it, I hit set position. Then you're going to come to a screen that says circumference. If you have a tape measure available, you can then take the circumference of the tree at breast height, about 4.5 feet above the ground surface, all right? Now I should also mention that since we did it this way, we're on a flat surface. If you happen to be on an area that's very sloped, like you're walking uphill to the base of the tree or you're walking downhill to the base of the tree, what you can do is you can pull out that tape measure, and from where you took the observation from originally, you can measure the exact distance from the location of where you were standing to the base of the tree. And then you can put that information, excuse me, in this section. This section here is the review section. It gives a camera height, the stride length, the number of steps you put, distance to the tree, and then in the yellow section, the calculated tree height. And if you don't like something in here, or you took the actual measurement from the base of the tree, from the location where you're standing to the base of the tree, you can hit the edit button
and you can put that distance to tree right in here. So once you do, you just hit finish, okay? So then all that information then will be sent to the GLOBE database where researchers, student researchers, professional researchers, and citizen scientists can access that information. So I'm going to send my trees data now, and it's being sent to GLOBE. And then there are places on the app that you can go look to see where you actually took your tree height observations. So before we finish, okay, that's the actual tree height observation, okay? But before we finish this little clip here, a couple things I want to focus on to make sure that you remember is that you always want to keep the phone at eye level when you're taking the measurements, okay? So always at eye level. That's the most important part, because if you look at the base of the tree and you go like this, or you go to the top of the tree like this, you're changing the angle at which you're viewing the base and the top of the tree. An important thing to remember is that if you have multiple people taking observations using the same device, what you need to do is you need to change the height of the observer each time, because we're assuming that they're going to be of different heights. So if they're of different heights but using the incorrect height, the tree height observation will be incorrect. It'll be an erroneous tree height observation. So how you can remedy that, when you go into the trees tool, there's a little question mark. That's the help section. You click on help and it says change current user height settings. So when you can do that, you can go right in and change the height of the observer about to take the observation. So hopefully all this helped you in understanding how easy it is to take a tree height observation using the NASA Globe Observer Trees tool. Have fun using the NASA Globe Observer Trees tool, and thank you for all your vital tree height observations.
So I hope that you learned a little bit about how to take a tree height observation. For the sake of time, I didn't do the tree circumference, but you understand that you can do that as an optional observation, and that also helps scientists with the whole carbon budget of the tree, how much carbon is being stored by the tree based upon its size. So let me show you a little bit of the data that I got from these trees. Now, here everyone and I found an ICET2 measurement of this tree. All right. And this is, as I mentioned, in Salisbury, Maryland. And as you can see, I got a photon that aligned to it. And if you look at the bottom, you can see that the NASA GO tree, and I should mention that in this location where this photon hit, how the photon was not really centered directly on the tree, but the outskirts of this photon hit the tree, but it hit no other tree. It was returning the height of that tree. So here we have a tree height that came back from NASA GO of 19.41 meters. All right. Now, what I got was, if you look here from ICET2, you get 19.12 meters. So that's pretty close. 19.41 from the app, from the NASA GO Trees tool, and 19.12 from ICET2. Super close. All right. Now, one thing that's really cool here is that, as you can see here, ICET2 measured it July 31st, 2019 at 19.12 meters. The one I just took and showed you the video of was March 15th of 2020, and that came out of 19.41 meters. Now, what I mentioned earlier, a crazy thing that happened. Many of you in the United States on the East Coast remember Tropical Storm Isai, right? That happened around August 4th. It came ashore early August, but it hit my location up here in Maryland, on the eastern shore of Maryland, August 4th of 2020, where we had very high winds. And what happened is that half of the tree snapped due to the wind. So it had extreme wind damage. And that is something that's very important here, because if you look at the observation I did just last week on February 3rd, you will see that the tree height dramatically changed. Okay, look at the one on the right side here. The tree height for this now was 16.61 meters, almost 3 meters difference Okay, and you can see the tree shape is completely different. You can see in the March 15th one that we have a full tree. On the one on the February 3rd, 2021, you can see just about the right side of the tree is completely gone. And right up in the center where the tallest part of the tree was from the March 15th measurement of 2020, you can see that's gone. So the highest part of the tree is on that left side of the tree now, which was about 3 meters shorter than it was in that center section of the tree from last year. So this really showcases, you know, just this change, just the tree being damaged caused a tree height difference of 3 meters, which also means that this tree is half the tree it used to be. So therefore, it's pulling in less carbon dioxide from the atmosphere. All right. It's also pulling in less, also storing less carbon because of it's a smaller size. And also, it's in a different stage of photosynthesis. If you look at the one on the left side, you can see the buds are starting to bloom. Okay, so there's that really highly active photosynthetic state of the tree. Look over to the right, no blooms, no buds. Okay, so it's basically this tree's in a relatively dormant state. So photosynthesis has really slowed down to the point where it almost stopped during this time. Okay, not 100%, but as you can see here, you know, you have a big change. Now, what I also did, all right, one thing that's important here is to take these land cover observations using the NASA Globe Observer, because if you haven't used a land cover tool, you should do that. But what I did was, when I took the tree height observation, I went to the base of the tree and I did a land cover observation. You can see on the left side here, I have the up photo, which shows you basically that canopy, all right, that tree coverage. And then the down photo, the ground, as you can see, it was just after a snowfall. So that's super important because the one tells us what the environment was like, meaning, you know it's winter, right? You know the season is winter because you have snow on the ground. When you look up above, you can see what that tree canopy is. And then if you go over to the right here are the land cover shots from the app in all 4 cardinal directions. You see north at the top here where you can see part of the tree and some ground surface and this pond. And if you look off to the east, you'll see we hit a little residential section. We hit someone's yard with their home. And then if you go to the south, we have the road, a little bit of snow-covered grass, and then a home in the distance in the trees. And then off to the west, we have the other part of the pond that you get from the north side, but this is the west side. Looking west, you have this part of the pond and you have part of the tree and my vehicle there on the road. So this really shows you the different levels of land cover that you can get from just a single picture, and the importance of it. I know Peter Nelson is really keen on this too, is one of the most important parts of looking at tree height is also looking at that land cover of that up photo, looking at the tree canopy as part of that land cover. That's such a super important part. And what this does is this combination of the tree height observation with the land cover gives you a much more precise and robust data set to analyze that local environment and what's happening there. So those are all the slides for me, and I will go ahead and pass it over to Dorian, who's going to talk to you about taking tree height and land cover observations together. And I will stop sharing my screen.
Sounds great. Thank you so much, Brian. And wow, Antonela, your presentation was just simply fantastic. I love the fact that you used what you were doing for your math class. We don't often hear about that. We often hear about science class. So super exciting. And Brian, how I loved being with you and listening to the geese and enjoying your tree height measurements. So thank you so much. Are we able to now see the taking tree height land cover observations together? Awesome. So let me go ahead and go to my next slide. I'm going to try a little thing here where I've taken a couple of videos and I've stuck them into this presentation. And so we're going to give it a ride and see how it works. Because we're coming from all over the world, I wanted to show you where I'm located. I'm using my my home trees, as I guess most of us are nowadays. So I'm over here on the east coast of the United States, not quite to the bay. And if we go in closer to near where I live, Washington, D.C. is about a half hour away from me if I drive south. And I'm out in a section of Maryland that is pretty interesting in that it used to be farm. And now it has become much, much more urban, but there are still farms around us. And we've also, I guess, because it's a more recent settled, as in people have kind of taken the farmland and started, sorry, I tried to turn this off, but I haven't yet found my button. People have started taking the farmland and building houses as people start to move out more into the country. So the area that I'm in has lots of nice woodland areas. We've also got lots of farms around, and then lots of different housing developments. Now that's important because as we're looking at the tree in my yard used to be a farm field, so it didn't have any trees. So the first thing I need to do is pick, I planted a few trees a few years ago, and I need to pick a tree to measure. And let's come over, select a tree and a land cover observation to do. So I walk over, let's come over here. Walk over to my tree, like over here, and I decide, I don't walk all the way over to it, but I decide which tree I'm going to do my tree height measurement of, and that will also then inform me of where I will do my land cover observation. Alrighty, I've got my tree in mind. I'm making sure that it is at least 5 meters away from me. And I also want to be sure that I can take a picture of the whole tree. So I'm going to stop about here, and then I'm going to open up my app. All right, pretty easy so far. Tree in mind. Oh, come on. So now let me go to my next step. And once it's open, of course, I'm going to select tree height to begin with. And then I'm going to do that old thing where I hold my phone nice and steady and I take the picture of the base of the tree. And then I go up and I take a picture of the top of the tree. And then I take a picture of the tree straight on. And then I walk to the tree. 1, 2, 3, 4, 5, 6, 7, 8. This is a part my little granddaughter, 11, who's 3, 12, loves to do 13, with me. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 and a half. All right, so and once it's open, of course, most of my, whoops, come over here. Got most of my tree height. And once it's open, of course, I'm going to select. All right, sorry about that, guys. So there, I did my tree height measurement, and I had taken a picture of my tree. So then when I look at my measurement, I can, go and look at any of my data. I have the date that I took it, that I was using the app, my latitude and longitude. I happen to usually do my observations as part of the GPM satellite mission that I support, my site name, and then how tall my tree was. I'm looking at this in meters here, and then what my surface conditions were. All right, so now it's time to do a land cover observation. And once I have my tree height finished, I told you I also want to do land cover. So as you look around here, you're going to see that I'm looking in some neighbors' yards. So I want to ensure that I do not see their license plate numbers. And I'm also going to make sure when I take my pictures that my phone's kind of pointed down a little bit. I don't want any people in here. I don't want any addresses. I don't want any street signs if possible. Basically, what I want to do is I want to characterize what the land is like and what types of trees and bushes and other vegetation are on this land, as well as give a little information about percentages. What percentage of the land that I'm looking at is covered with, say, tall coniferous trees versus deciduous trees? Do I have short bushes or tall bushes? Do I have grass, pavement, so on and so forth? All right. And once I have my tree height finished, next slide. Make that small again. Tried to get a little too fancy here. Exit full screen. Go away, silly thing. Escape. And once I have my tree height, does not want to let me get back. Okay, fine. See if I get fancy again. Next slide. All right, here's a couple of hints. And one thing you may note is from my tree here, as I'm going to take my land cover observation, in some of the directions in which I'm looking, I can get a pretty good view, at least a football field's worth of view. But there's a few other places, say where that fence is, and that fence, and over here where I've got this tall barrier of cypresses, and even my house, where I'm not exactly getting as far of a distance as I would like, but that's okay. You would like to get some land cover observations where you are able to do that, but in some cases you simply aren't. So that's the thing you're going to find when you're doing this at the same time as the tree. You know, you don't have to worry about it, that open, you know, homogeneous land for the football field or the 50 meters. So here you were looking at my data. What I generally do is I stay outside unless it's really cold out when I'm doing my land cover characterization, because it's easier for me to be out there and be looking at the trees and try to determine, okay, when I'm looking north, about what percentage am I looking at of grass? About how tall is it? How much is pavement, say over here in this picture looking south? About how much of what I'm looking at are deciduous trees versus coniferous trees? And so here's that characterization down there. Remember though, that's kind of extra for experts. You don't have to do that characterization in order for you to have completed your land cover observation. Kind of like when you do the tree, the tree circumference. You can do it and it's great, but you don't have to. All right, so I hope you saw just how quickly I was able to do my land cover classification as well as my tree classification. And now I'm trying to make it stop sharing my screen. Hopefully it did.
Yep, you did. Thank you, Dorian.
You bet.
All right, and the time remaining, what I will do is I will quickly pass it over to Peter Nelson to talk to you about the story mapping.
Well, hello, everybody. Thanks for joining us today. Since you've learned a little bit about actually getting the data and making some of those measurements, I want to highlight a little bit about how you can take the data out of the GLOBE program's database and add it to a map. And this is a really important piece of your scientific data, helping people to understand where you're actually working, this study area, as we like to refer to it. And so I'm going to be demonstrating how to do this to take us into the ArcGIS program. And that's to build off of the idea of creating a story map from this. So we're going to hop over here, and hopefully you all know how to work with the ADAT system here in GLOBE. If you don't, download the PowerPoint or watch the video. But here I'm going to demonstrate first getting the data out of the database, and then so that we can upload it and actually create a map. So if we go into the advanced data access tool here, I'm just going to select just some tree heights that may have been measured. And if I filter out and just make a selection off of that, the next thing I'm going to do is look for any trees that are nearby. And so you need to look up and find out what is the latitude and longitude, the location on Earth where you are doing your study area. And so you might focus around your particular school or around your city to be able to bring in all the data that you have are interested in. So where I'm located is at 45 degrees north and minus 123. And I'm just using whole numbers because of where I'm located is pretty close to where those two lines cross. And I'm going to just look at any trees that are around 20 kilometers from this location. So I'm going to add that filter. And then I'm just going to filter out. And I notice here that there's 13 sites. And that's really important to recognize because the GLOBE program puts everything onto sites. And so if you have citizen science data, like what we were just looking at coming through the GLOBE Observer, it will have this sort of funny looking name that refers to a particular 100 meter by 100 meter area. Or you might actually have locations that have been defined by a particular school. And so this, just by looking at this data set, data table right here, you can start to get an understanding of who created that data and where it's coming from. And to actually get the data, I want to obtain the measurement data itself. And so you can see in those 13 sites or 13 locations, there's actually 15 tree heights that were measured. So it will take a little bit of time as the data gets packaged up and rolled up and made available to me. So, you know, you can wait a little bit. If you have a lot of data, this can take a couple minutes to actually roll up and access. And as soon as that is available, you'll be able to download it in a zip file. So this is a compressed format that that puts the data table into a package that allows you to download it pretty easily and quickly off of the internet. And so, like you can see, even for these 13 records, it can take a little bit of time to access and get the data itself. You can access the summary data, which instead of getting the 15 tree height measurements that were made in these locations, it will summarize that and provide the data in a slightly different format. So you might want to try both and see what the difference is in the data table and for your particular research question. And as soon as that's ready for download, you get this option right here, and you can then download it. So I'm going to save that file, and then I can go up to my browser window here and open that up. And you'll see that in mine, I have a variety of files already downloaded. You'll see that it gets named in a particular way. And then I need to open up that zip file. So there's a variety of tools that allow you to actually extract that data. I'm just going to use this archive utility. And now you can see that I have this .csv file, and this is a comma separated format that is generic. And so, and that allows me to work with it in a lot of different types of software packages. In our case, we want to look at this because we need to format it. So I'm going to use Microsoft Excel as a way of looking at this. And so you can see now we've downloaded the data and we have some different field names. And so you want to go investigate and find out exactly what these mean. But some of them are straightforward. And we can see here in the second line, the first line here going across, we have the field names that are stored in the database. And you can see at the beginning, we actually have the name of the protocol that we downloaded. So it allows you to keep track of what you're actually measuring. In the second line, you'll actually see inside of here some of the descriptions that are actually included. And this is something that we need to remove before we can map this. So I'm just going to highlight that and delete that out. Most mapping software will not understand that second row. It really just wants to see this first one. The other thing that we're going to do here is this latitude and longitude column refer back to that site ID. So one of the things that I'm going to do to help us with the mapping, because I want to see the actual locations where we measured these, I'm going to change this and call it site latitude. And then I'm going to call this one site longitude. And because when you look down, you can actually see the locations where they are the same site, the same 100-meter area, right? And so when I actually do this mapping, we're going to want to go all the way over here to the edge. And here we have the measurement latitude. So I'm going to just fix this database a little bit and call this the latitude and longitude. And that will help us when we actually do our mapping. And so if I change this right here to the latitude and longitude, our software will automatically recognize those fields as our coordinates. One thing to note is that here in our very first column, we don't actually, in this one, we don't have a latitude and longitude for those exact locations. So to me, when I go to map this, I actually I could use this latitude and longitude. But in our case, I'm actually just going to delete that one out because I don't know exactly where that tree is located. And so, that's one of those considerations that when you start looking at the data, you can start to see some different challenges and issues. One of the things that I'll highlight is that this one was recorded back in 1995 at the very beginning of the GLOBE program. So you can actually see by using the Globe Observer app, you have a little bit more data completeness than some of the historical data that you might find in the database. So you need to spend a little bit of time getting to know your data so you can actually actively get exactly what you're after here. So you have to spend a little bit of time cleaning up the data. And that's an important science skill that we all spend time doing so that we can minimize some of our errors. But I'm going to just delete that row out completely. And I'll record in my methods that I removed that data so that I can track and report it in my final report. One of the important things that now that I've looked at some of the data and I can see what I actually want to record inside of here, I now need to save this file again. And remember, this is saved as a comma-separated file. And to be able to save it in that same format, I want to actually highlight all of the records that I want to keep. And otherwise, Excel will end up only keeping that one cell. So what I will actually do is go up to my File menu and click the Save As button. And you can see that I want to use that same file format of CSV, but I'm going to change this to make the name a little bit more descriptive. So I'm going to select tree height and I will call it Peter's study area. And then, again, you want to have a good descriptive name so that you can keep track. You might even be able to pass this off to some other researcher. So tracking these are really incredibly important skills that you want to spend a little bit of time doing. So you'll usually get this alert, and this is one of these file format things that really matters when you're working with a computer. So here it's just alerting me that I might lose some of those features that Excel likes to keep, and that's totally fine for this format. So I'm going to say yes there. So what I can now do is go to, you should, if you don't have access through your school, you might ask your teacher about having access to this ArcGIS online software platform. And there's a lot of tutorials and hands-on tutorials that allow you to actually see how to work with this. You can explore a lot of the different types of projects that other people are working on, whether it be tracking COVID or whether it be tracking wildfires, air quality. There's a lot of really interesting sort of features that you can learn about here. So as you're starting to think about your own project and summarizing it, make use of this resource. And you can get a free trial access to this, but as a student, you can also hopefully have access through your school. But that's something to really consider about mapping software is making sure that you get something that works for your computer system and for the type of analysis you want to do. Here, I just want to put that data onto a map so that I can report it for the IVSS. Maybe do some summaries, do some spatial analysis, some geography research, looking at how close my trees are or making a map in that way. And so, when you actually log in, after you've logged in, I have a lot of maps and data that I've been working with here on my own. But one of the things that I want to do is first I need to get that spreadsheet that we were just working off of, that comma separated file, up into the cloud, into this software system. So I'm just going to add an item here, and you can see some of the different options of how you can access this. But since I have it stored on my computer, I'm just going to do a little search really quick and look at my downloads file. and look for the file that I just named right here. And so I'm going to select open. It's going to actually look through and analyze that data. And what's important here is that how can you actually know and place that spreadsheet data onto a map? And we're going to use those latitude, longitude coordinates to do this. And there's a variety of different ways of doing that, but you can see the field names that were in that database. And so you can see here's that site latitude, site longitude that we first, I had to change the name of. And you can see all the different field names that are there. And so we should be able to go down and find the latitude and longitude. And you notice that it recognizes by that name, latitude and longitude. So it's going to use those two fields and the data in there to actually put this on a map. One of the things is you want to publish this as a hosted layer. And that means that once it's put into this ArcGIS online environment, it's stored there, and the spatial data then becomes something you can work with and you can actually put on a map. So it sort of transforms it into something that you can work with. One thing I'm going to do is add some a tag to actually make them searchable and recognizable for other people. So I'm going to add this tree tag, and I'm going to click add item here. And so it's going to take a little bit of time, and it's going to process that. And then one thing I'm going to do is just open this in the map viewer. And what it should do is show me old data. And that's not at all what I want. And so what you can actually see now on here is it loaded up that tree height data. And so I can actually symbolize this. And right now it's just showing this by elevation. And you can see the different locations that where they're located out there. But I'm going to change this and change it to just the single locations here. And I can get in and actually change this symbology of this location to something like a green color, and I'm going to make it a little bit bigger. Right? So you can play around with all of those different options. And now it's really actually kind of hard to see where those are. And so what I need to do is go back, and I'm going to turn off a couple of these other layers that were in there. But now you can actually see on this base map where those tree heights were measured. And if I can click on them, and here you can actually see some of the different information that's associated with that. We can see this particular tree that we're looking at is 9.97 meters tall. So one of the things that you can start doing with this is hopefully you can go in and you can change the base map that's underneath it. You can show a satellite imagery, or you can actually change it to something like a light gray canvas so that those colors stick out a little bit more. And I'm going to save this map as my tree map. And again, I want to use a nice tag here to be able to do this and make the summary so that it's my tree map. But you want to be nice and descriptive about this. So I'm going to save that. And now I actually have this this map open and available to me so that I can add it to a story map. I can use it as something that is part of the whole presentation that I'm going to do. So I wanted to highlight how you take data out of the GLOBE database system for an area of interest and be able to make a map like this. The neat thing is you can share this out, and you can actually create a web app. You can do a variety of different things, including embedding it into your own story maps. But we're running out of time. And so I wanted to just really focus on that little aspect of taking data and creating a map for your study area of interest. And I will go through and make some other recordings, and we'll post that up to our trees blog about how to embed this and some of the interesting ways that you can use sliders or other ways of actually highlighting the differences between the different trees or the attributes of those fields that were measured. So I hope that you take some of this and are able to create a really exciting map as part of your IVSS.
All right, thank you, Peter. We have a question in the chat. Can we use QGIS or Saga instead of ArcGIS?
Definitely. The big thing right here is that ArcGIS Online is a full suite of tools that allow you to do analysis in the cloud. There's even some NASA data that's up there, different satellite imagery. And then importantly, you can turn that into a story map, and it's all encompassing. But you're right that QGIS allows you to, a different software package allows you to do more analysis, and you can create your own study area maps using a variety of these GIS, Geographic Information System packages. And so, you know, don't just take this as the only way of doing it. Software engineers are coming up with all kinds of interesting ways to access this and to be able to create your own maps and to be able to do some of that analysis. So I'll make sure to also highlight that as an open type of software that allows you to do this without having to work with this particular cloud-based system. But it's really incredibly powerful, and you usually can get access as a student to some of those developing software, the different tools that are available inside of there. So we'll make sure to highlight that on our blog so that as everybody's racing to finish up their IVSS projects, we can help you actually show us where you're doing it and maybe do some spatial or geographic analysis around it. So that's a great question.
Excellent, thank you, Peter. And that reminds me of something when you said, you know, one of the things that we try to push out with the tutorials that you do, Peter, is that there isn't only one way to do something, because on the page, and you can see it up in the comments, and I'll just post it here again. This is a short bit.ly link that I created, but this takes us directly to the tutorial section of our Trees Around the Globe Student Research Campaign page, where we have different ways that you can look at the data using different online tools, analyze the data, you know, so many different ways through what you know, ArcGIS, there's Collect Earth, there's all NASA Worldview, all these different things. So, you know, that's one thing we like to stress each webinar, is that there's not just one way to do something. Story mapping. So, you know, there's lots of ways you can do it. And that's what we want. We want you to feel comfortable, you and your students to feel comfortable with whatever online tool you use. That's why we're trying to showcase how to use them, in a user-friendly way for your research. And you know, I know it can be overwhelming, and I know Peter works on these all the time, and I'm pretty sure, Peter, you might get overwhelmed, you know, every so often, because there's lots of data, lots of different places to go, lots of different tools to use. What do I choose? And that's what we're trying to do with these with the campaign webinar from last month, and then today, and then, you know, the last one before IVSS is due next month. So does anybody else have any other questions before we end the webinar? All right, well, thank you everyone for joining us, and you know, until next month, please stay tuned. You'll see an email once again come out from me when the recording is available from Zoom and up and archived on our website. So thank you all again. Thank you to Antonela for presenting a research. It was great. I mean, like as Peter Falcon mentioned, there were lots of great comments and questions in the chat. So thank you once again, and we're looking forward to seeing you know, where you go with this research next. So thank you everyone, and we'll see you next month.